Hello everyone, my name is Matt Babbitts and I work here at Clark Public Utilities as a project manager in our Energy Resources Department. And one of the programs I work at here at Clark Public Utilities are our solar energy programs, and they're a lot of fun to work on. Let me tell you a little bit about how it works. You might be surprised to learn that in 1 hour of sunlight, there's more energy than the whole world consumes in a whole year. And that's a lot of energy. So let me explain how it works. When the sunlight comes down, it contains energy that we call photons. And the solar panels are able to capture those photons, take them in, and convert them into electricity. So the way those solar panels work is they're filled up with something called silicon solar cells. And those silicon solar cells have the capability to absorb those photons, the energy that come in the form of photons, and convert it into electrons. When that happens, the electricity is created in something we call DC, or direct current electricity. And unfortunately, we can't consume that kind of electricity at our homes, schools, and businesses. So we have to convert it into AC, or alternating current electricity. And there's generally a device called an inverter that's attached to the solar panel that does that conversion process for us. Now that we have a basic understanding on how solar energy works, let's take a look at a real-world example. What we have here is a solar panel, and we're going to pretend that these two lights up here are going to be the sun. Now this solar panel is hooked up to a small electric motor behind it that blows compressed air up and will actually push that ping pong ball up the tube when it's running. It's morning time now and the sun's about to rise, and let's see what happens. So the sun starts shining, the photons within that light start being converted into electricity by the panel, the electric motor starts running, and as you can see, the ping pong ball was pushed all the way to the top of that tube. Now let's do an experiment and pretend that my hand is a cloud coming in and blocking some of the sun and see what happens. So as the cloud comes in, it's blocking photons and there's less electricity being made, not enough to power that fan, and you can see the ball fell to the bottom of the tube. But as the cloud starts to move out of the way, more photons are creating electricity, the motor starts up, and the ball rises to the top of the tube. Now you might be thinking that if you're not a homeowner, you can't participate in solar energy because most systems that we see out in the community are rooftop mounted solar panels. The good news is there is another version of solar that you can participate in, and that's called community solar. So how community solar works is it's a combined effort from many members of a community that pool their funds together to build a large solar array. That solar array is interconnected to the utility grid, and the participating customers get annual energy credits for their portion of the clean, renewable energy that's produced. Here at Clark Public Utilities, we have quite a large community solar array. It's comprised of 5 separately metered solar arrays for a combined system size of over 300 kilowatts. Let's talk a little bit about how it worked here at Clark. So the first step was the utility needed to select a suitable site and develop the project on behalf of interested members of our community. We selected our operations facility here because we had a nice large field that has great southern exposure that will capture that energy in the sun all year round across the calendar. After that, we had to recruit customers to participate and fund the program. Our project here is comprised of over 700 participating customers at Clark Public Utilities, and they funded this project back in 2015. In return for doing that, each year those 700 participants receive an annual energy credit that represents their portion of the electricity produced on the site.